Hello, good day, guys. I am Jordan Balansot once again, and we are going to do the activity 8 of our EM lab activity, which is titled EMF generation of DC generators. So, let's get started. So, now as you see here, we already got the setup needed, which is the arranging it by installing a power supply, data acquisition mode, prime mover dynamometer, and the DC motor slash generator. And we also lowered the panel to include the belt. So, and first, make sure the switch of the power supply is off and the voltage control knob is full counterclockwise. And here we go. Because we already did configuration, so it is not automatically set into zero right now. So now next is same process. We connect the power output of the data acquisition module in the prime mover dynamometer to the 24 volt AC output of the power supply. Then set the 24 volt AC power switch to the I position to turn it on. And afterwards, start the data acquisition software. Then finally couple the prime mover to the DC motor. Now using a belt and set up the separately excited DC generator connection as shown in figure 1, which is here. That one, we are going to do that configuration and let's get started. AC. Now it's all set and done. Now what we need to do next is to set the field restart to its maximum resistance by turning it fully counterclockwise. Then we turn on the main power supply and carefully adjust the voltage control knob while ensuring that the motor speed does not exceed 1800 RPM. Set the max, or something like that. We try 60 or 65, 60. Then let's record the measured voltage, motor speed in RPM, and the percentage settings of the control knobs during operation. So the so it's already 83.10 at 100%. So I think it would be better if we lower their voltage control into set it at 50. You know, in that way we can match the corresponding values in the table. So now our voltage knob percent is 50%, and the field restart knob percent is 100%, and the voltage E sub 1 is 68.40 volts, and the motor speed is 1248 RPM. Now without changing the setting, we do it again. We need to reach the 80. Around 68% for the 80 volts, and we got 1246 RPM. And for the 90, let's try about 60 or 65. Oh, got wrong. And for the 47% for the 19 volts with just 1245 RPM. The next is for the 110 volts. I think we should try 37%. Snapchat. How about 34? Snapchat 30, 29, last 28, one more 27, change. 27% for the 100 volts at 1024 RPM. And for the 110, let's try 20%. How about 11%? And we got 8% for the 110 volt, which is at 1243 RPM. And lastly, for the 120 volts, let's try 1%. This is ratio, this one. At 0%, we, for the 120 volt, which we didn't reach, we got 1443 RPM also. So the question is, does the voltage increase while increasing the resistance of the rheostat? Yes, increasing the resistance of the field rheostat increases the field current, which strengthens the magnetic field flux, and it shows that a stronger magnetic field induces a higher generated voltage in the machine, causing the output voltage to increase. And for the last step, we all return all the knobs to its minimum position and switch off the main power supply. 0%. So check now, and we'll turn it off. And that's all said and done. So thanks for watching, guys. That's all for the activity 8, and the conclusion will just be shown. Thank you for watching.